Yeah, good morning. Not sure where everyone else is. I think they're having a hard time getting up on Friday. Okay, well, let's get started. I'm figure everyone else is sort of straggling whenever they're going to do what they're going to do. Last time I was talking about different vegetation zones, and I've gone and pulled some images that'll give you an idea of what these look like. So this is from our Kaiwi project we did for state parks back in, I don't know, about 10 years ago, where we surveyed the whole area from basically Sandy Beach over through Makapu and up on the highlands above it. So this is a real good example of a 21st century strand vegetation. You've got your area here that's in constant breaking waves, so there's no vegetation that can survive in there. And here you've got your beach Naupaka. You can see how tiny it is in here, and that's simply due to the fact, let's see, there's a little bit more here. And that's simply due to the fact that with the enormous amount of salt and the limited amount of water, this is as good as it can do. It's actually very typical of Hawaiian vegetation that rather than what you'll find is opportunistic species move across environmental zones. Probably the most famous will be the ohia, which we'll see a little bit later. But beach Naupaka is on one hand, as I think I mentioned last time, it's designed specifically for salt conditions, or it's built itself for salt conditions. But you see it fairly far inland if there's the right amount of water and humidity for it. In fact, we've got it all around the building here on campus. It's one of the main landscapings they use on campus. And the leaves here, an individual leaf here might be the size of that entire plant. So what it does is typical Hawaiian plant strategy for indigenous species is they change their size and they change the height. Naupaka here, and even for example in the hotel resorts, will be about 4 to 6 feet high. It's a big bush. You notice here it's very much a very low ground cover. And that's due to the fact with the prevailing winds, there's often a huge amount of time there's wind blowing across here bringing salt. So these things are going to be as close to the ground as possible. One of the main reasons being that you have to remember as you get wind moving across the surface, it tends to increase evaporation. So if you're a plant and you're already having trouble with getting real good water, the last thing you want to do is to increase the chances you're going to lose water through evaporation or molecular transpiration. So a typical Hawaiian strategy is in elevations where you're at risk, you keep yourself scrunched down close to the ground to minimize the amount of impact the wind has on you. You keep your leaves small to cut down the amount of sun resistant or sun damage, also to minimize the surface area that the salts are going to land on. So rather than a different species, what you find is a single species has modified itself for different conditions. Now, if you're someplace else in the world where you have a lot of different diversity of species, there would be different species in each of these areas. You wouldn't see this, one species playing games like this. It wouldn't have the chance. There'd be more optimal plants. In fact, you can see here if you even just look at this side. Here you're only about 2, maybe 3 meters away from these guys, but already because you're a little further back from the shoreline, these are substantially taller than their twins over here. That again is very typical of Hawaiian vegetation, where you'll see pretty striking diversity in terms of shape, size, and other conditions. based on literally about as small of a microenvironment as you can think about, 3 meters. So this is a very typical example of what you see in a Hawaiian strand vegetation system. So it's very limited. It's actually very fragile. People walk across here and just walking on the napaka kills it because it's so marginal in terms of its ability to survive given the salt and the other conditions. So these are they're on one hand, they're durable in the sense they can survive pretty striking environmental stress. On the other hand, they're very fragile because they've never developed a resistance to large animals and such like that. And napaka is, still a pretty good example. It doesn't deal with being walked on at all well. So this is a real typical strand. Let me get a few more images here. Oops. I gotta do this again. Okay, here's another example, a little further Malka, just inland at another image. So here what you're doing is you're getting on the border between strand conditions this way, and what you might call just sort of your inland lowland conditions on the other side. So here what you've got is a salt pond. This is brackish water. And not surprisingly in that what you've got is a combination of mangrove, which is this thing here. There's a little bit of napaka around the edges. So this is, again, remember mangrove is one of the 3 basic saltwater opportunistic plants. And here you can see the roots. Right? Let's just Here you can see the classic mangrove strategy. You run roots into the surface, and that filters the water, which then you use. A mangrove again has very hard leaves, just like an napaka, so it again can limit the amount of damage it takes from salt. So in fact, over here you can see it even better. Here you can see the classic, sort of saltwater strategy. Not surprisingly, mangrove is sort of an interesting situation. Mangrove is a huge problem here because it causes a huge amount of damage in the nearshore areas. In a lot of the world, you actually find people planting mangrove because, among other things, this provides a superb habitat for a number of small fish fry and other types of species. If you get into someplace like Southeast Asia and other East Asia, where you find this is a regular, that's where it's from, you find there's whole biotic systems that are based in mangrove roots, very, very complex systems. Those haven't developed here because mangrove's only been here for about, I'm going to guess, maybe 150 years. So here it's actually a problem. And in fact, in a lot of areas, we go and pull it out of the ground. I think they do that at Kaiwi. But I would think that's a lost cause to bother trying because it's just an incredibly aggressive, very durable species. Now notice to the side, over here, you see what happens when you get out of the salt. The winds coming across here basically come across this way, across Makapu or Kaiwi Point. They come down this way. So what you see is basically 3 layers. Here's your strand salt vegetation. Not infrequently, you'll see a barrier line. Then what you've got here is your imported grasses. And then what you see then here is your taller plants that are able to tap, some maybe access to water. So this is your typical lowland vegetation. Notice how it's pretty sparse looking. Ironically, traditionally, say a couple of 100 years ago, this would have been a much more sparse. All you would have had would clumps of peely grass, and most of this would actually be bare ground. So the dryland or the leeward Kona sides of the islands were pretty brutal looking in a lot of areas compared to what we see now. At least now you get a lot of grasses growing. This hillside's covered in grass, which it never would have been, a couple of 100 years ago. So everything you see in this picture, including the mangroves, is exotic. The only species you're going to find, and this is actually unique to Kaiwi, which is one reason it's a protected area, is there's actually these species of Hawaiian cotton that's found in this area, which has managed to keep a toehold. It was probably one of the few plants that actually lived down here anyways. And it's managed to keep a toehold despite the encroaching grasses and stuff like that. You find it sort of scattered through here. But everything else here, this is all Koahaole and Keawe. So this is all imports. There originally would have been little clumps of Milo or something like that up in here. But most of this area would have been pretty bare. So this is basically your lowland vegetations. Let's move just a little further back here. Stop that. Oops, hang on a second, I do some sequence here. Here we've moved a little further inland. I don't remember exactly where. I think this is it here. This might be the cotton as I remember. It's got a pretty distinctive shape to it, but it's, again, here's the cotton right here. But it's the same height as the rest of this stuff. So these are all imported grasses. None of this is endemic, and none of this is imported by pollination. So this is all post-contact. Most of these grasses were actually intentionally imported in the 1840s through the 1860s to provide feed for grazing animals, which is also why the Hawai'i koa and the keawe were imported. They were imported to provide a grazing feed for the animals. The grazing animals have been brought in, which we'll get into later. So this is your typical lowland coastal vegetation system, except it would have been a lot more bare. And from a Hawaiian standpoint, one of the huge problems you get is there's not really a lot that's usable here. Native cotton, we don't have any accounts of Hawaiians using the cotton for anything, which is sort of odd because it's short, but you could use it for packaging or battening, or even, for example, as a poultice pattern for wounds. But they had a name for it, but there's no record they ever used it for anything. So what you've got here is sort of the traditional system. Now, if we move a little further inland, in other words, we start to get a little bit of altitude, and more importantly, where we start to get a little more rain blowing down off the slopes. So I'm going to do this in two phases. This is sort of so clunky. Okay, here's your classic lowland Kona or dryland side of the islands patterns. I mean, you see this in all the islands from maybe 3 to 4 meter elevation just inland of the shore, all the way up to about 500-600 meters, if you would, 1,000 foot elevation. This is your classic, and all of this again is exotic. This is the three sort of classic plant systems you see. A series of imported grasses. Someone probably knows what they are, but I'm not a botanist. I can never remember. There's about 3 or 4 species all mixed in together of grasses. Again, all imported as feed. Here's your koa haole or Hawai'i koa. You see this a lot here on campus, everywhere in the Hawaiian Islands. This was imported. It's from Africa, I believe, somewhere, Southern Africa, I think. This has sort of 3 functions. One is it's a nitrogen engender. In other words, it puts nitrogen in the soil. So it was planted in some cases to actually rehabilitate soils. The seed pods, goats and sheep like the seed pods. So if you ask your grandparents or maybe great-grandparents right into the 1950s, something that kids do used to make some cash, is they take old burlap bags and then go and collect the seed pods from the Hawai'i koa and the keawe, and they'd bring them to feed places where they were feeding pigs or cattle or whatever, and they get paid a small amount of money to bring these in. So that served that function. Also, most of the grazing animals, especially sheep, will eat the leaves. Will eat the small fronds, the green fronds. Here's a keawe. You can see a keawe over here. You guys should be intimately familiar with that. That's the one that's got the horrible spines on it that go right through your shoes. Here's a larger keawe here. Again, brought in from Africa. Again, I think the savanna regions. All of these plants have in commonality, they're very durable. They can take high drought, low rain conditions, and they're real survivors. Keawe, you're probably most familiar with it because they make charcoal out of it. It's a very hard wood. Keawe has been a huge nightmare here in the Hawaiian Islands, in the fact that it was brought in intentionally, but as with a lot of the stuff in the 19th century when they imported it, they didn't think of the environmental consequences of it. They just wanted something, so they just sort of went down and grabbed this and put it in thinking, oh, it'll solve this problem, without realizing they basically were giving themselves a whole package of other problems. Well, all these are very aggressive, so there would have been native plants in this same location. They're gone. We estimate there were probably 3 or 5 different endemic species of plants that existed as part of Kaiwi. And they're not there anymore. The only one that survived is the cotton in the lower elevations. So this is now an entirely exotic landscape. And this is typical of all the Hawaiian Islands. This picture could be taken in Kailua Kona, right off of Ali'i Drive. You could take this off of East Maui and Makena. In fact, if I didn't know better, I could tell you this is Kihei. On Kauai, this would be around, Poipu or someplace like that. It's the same on all the islands. In fact, worst would probably be Niihau, where this is what you'd see. So this has now become the Hawaiian norm. for lowland. And this will persist up to about 1,000-foot elevation with very little variation except maybe in the size of the plants. So this is the new norm, if you would. So this is now what's lowland vegetation. And I think I mentioned last time, the lowland vegetation system is the one that got most dramatically, completely changed. One, the Hawaiians had modified it extensively for what they were going to use the land for, which we'll see when we get into the next module. And on top of that, the Europeans that come in, this is the area that they see as most useful because they're the main money they want to make, and also the chiefs want to make in the early 19th century is grazing animals. All the money was in beef. Beef, sheep, and goats. So what you do is you convert all the area that you can into grazing land to then raise these animals. So let's switch and show you the last of the lowland pictures here. What happens if I do that? Okay, look at it easier faster this way. Notice what happens when you get a little more elevation. This was also, I guess it was about 2 or 3 months later, and there'd been some rain. So these are actually the same grasses that we saw in the last image. There's more rain. We're upslope about maybe a 15, 20 meters higher elevation. So we're also a little closer to Waimanalo side, so there's a little more rain that blows across the ridge here. So this area gets a little more water. Here you see a clump of keawe. So what you've got is the grasses. Notice again, you've got halikoa or koahauli here, and also a few scattered on the slopes, and the rest of it is keawe. So this is your 19th, 20th century lowland vegetation pattern. This is also, of course, one reason why you end up with huge problems with fires, and for example, the Waianae Range and something like that. All this stuff is basically almost pyrophytic. So you just look at it cross-eyed and it's going to catch fire. And as you might be aware, grass fires tend to move incredibly fast. If this area got lit off, this whole area would probably be alight in about maybe 2 minutes. Grasses just burn like paper. They just poof. They're not very hot fires, but they're incredibly spectacular. So this whole area is basically a modern version of this extent landscape. There's very little chance you could ever recover this landscape or return it. These are incredibly aggressive species. They're almost impossible to get rid of. So once they're there, you're just sort of stuck with them. So this is the lowland system we now have, on the dry sides of the islands. If you think about this, could be at Ewa or any place else, all looks the same. You go up into Makakilo, this is Makakilo. And again, notice how when you get a little higher up in here, the reason you don't see trees up in here is the total lack of any soil. So it's not an elevation thing. It's just literally the conditions are so bad that the keawe can't even get a foothold up here. Even the halikoa really can't. There's a few of the different types of cactus, which again were imported in the 19th century, in part as goat feed, which turned out to be a bad idea because goats don't eat that type of cactus. These are the big paddle cactus. Though they were also imported because you can actually take the flower part and you turn them into candy. I remember having that as I was a kid. They call it cactus candy, not surprisingly. So the flower parts are edible, but they don't harvest that here anymore. This is what's usually called panini here. Okay, so let's leave that. Okay. Okay, so that's our strand, and to a certain extent, our lower scrub upland. So these are your dry areas, but they're not. They're even in the Hawaiians, in the Hawaiian system of say the 1700s, they were sort of ambiguous in terms of what you were going to use them for. My area in East Maui has a lot of this scrub upland. This is all your lower regions. And pretty much what people did is they transited through it. We don't see any evidence of major land use or, agricultural structures or building structures between about 15 meters inland, in other words, from the shore, which was largely fishing stuff. And you see nothing till you get up to about maybe 100, 150 meter elevation, or 300 or 400 foot elevation. That whole area in between was basically, it was just a transit zone. People couldn't figure out anything to use it with, so they just sort of went through there. You do get some native plants, especially milo and stuff that like that area, which are a very useful tree. But again, they tend to be really small. They're real scrawny down that lower elevation. So it looks like the Hawaiians never did figure out a particular use for that region. It was just something you went through to get to something that actually had value. So the next major area is actually what we call the dry forest. So let's segue up slope here. Let's do this. Again, if you have any questions, ask, because I'm just sort of zipping through this stuff. Now we're back in East Maui. Now we're back in my stomping grounds. This is your upland areas in the 21st century. Again, remember that your upland areas, like your coastal zones, were very quickly seeded with exotic grasses because the main way to make money right into the 1840s, 1850s here, from basically 1800, was grazing animals. Because what you had is enormous numbers of sailing vessels coming in here, largely whaling ships, trade ships, that were coming thousands of miles, would rest in the Hawaiian Islands, basically fix up, parts that were busted, and they'd reprovision. And the main thing they wanted was salted meat. So it would come in here, and so very quickly the chiefs realized if they wanted to get European trade goods, if they wanted money, if they wanted stuff, they wanted guns, if you're Kamehameha, what you did is you took the grazing animals, put them in salt to basically preserve them, and then sold these to the ships. And this was the major industry here in the Hawaiian Islands for almost half a century, was ship provisioning. So basically the only way you could make any money here was to provide meat. And the way you provided meat was in the dry sections was raising these animals. You still see this. This is why in a lot of the islands, this is part of Ulapalakua Ranch. There's the huge Parker Ranch in the Big Island. There's Kualoa Ranch on this island. That's why you see the ranches and in an area you've got this open pasture land. That was part of this intentional strategy to maximize your economic viability in the early part of the 19th century was basically to do this. Now, actually, since I think that sort of came up before. Okay. Here you also see part of our geology. This is one of these coastal cones that's part of this rift zone. That rift zone I mentioned for Halakala actually runs back up this way. So here's one of the points of it. And I think, oh, here we go. Yeah. Here's Mokuli'i here. This is part of the rift zone too. So the rift zone actually went out into the ocean. This is pretty much its end spot. So this is another cinder cone like this one. This one, because of erosion, is partially collapsed and it's open. It's a real popular dive spot for tourists. Here we see poor old Kaho'olawe. Now, Kaho'olawe gets pounded in a later period of time for a bunch of dumb things that the military was doing. But it was always a fringe island because it's in the rain shadow or the lee of Halakala. And you can see one of the consequences of that if you look at the relative vegetation you've got here, which is all exotic. But it's pretty substantial. There's a lot of stuff growing there. And you look over here and that poor island's just been hammered. That's because it only gets about maybe a half to 2/3 the water that this does in terms of moisture. There's just almost no rain falls on Kaho'olawe. It's to all intents and purposes probably a desert island in terms of technical, in terms of amount of water. So what you get is fairly high persistent winds and very little in the way of rain. And the end result is an incredibly fragile island that has no durability. Here, if this gets burned out or it's a dry season, there's enough durability in the system here that it'll come back the next time there's a little more rain. Over in Kaho'olawe, if you end up with a big fire, it's going to be years before the area can even recover itself. And as we'll see later, the enormous number of goats here just have wiped the island off the map to all intents and purposes. So here you see your classic upland slopes. This is about 500, 600, maybe 700-foot elevation. So notice how it's a little different than down here, though partially that's due to tourism. But nonetheless, what you see down here is if you notice this section here is actually the same plants that are up here. But the growing system's slightly different because this higher elevation gets a different pattern of rainfall. It gets more rain. Most importantly, as we'll see, it gets more cloud, which is something we'll get into as a real important part of the different environmental zones here. Now, this is actually what a dry forest looks like. A little section of the area I do research in Hawaii is the Nature Conservancy set up a fence, but it was actually there already anyways. Is one of the few dry forest remnants in the Hawaiian Islands. Again, because the dry forest or the dry zone was the area where the animal husbandry, i.e. the ranching was taking place, this area gets completely wiped off the map. This was the largest environmental system in the Hawaiian Islands was dry forest, from about 700 or 800 foot elevation all the way up to about 3,500 foot elevation. But again, when the grazing animals come in, none of the Hawaiian plants in the zone had any ability to deal with grazing animals. They tended to reproduce very slowly. They weren't used to being eaten. They weren't used to being trampled. And especially the goats and the sheep, especially the goats, which are our nightmare here in the Hawaiian Islands, just completely devastate and wipe this environment out. Now, because people are making money off of the goats and the sheep and the cattle, to be honest, no one really cared. They didn't see this area as having, it had value, but compared to what you needed to do right now, people weren't taking the long view in terms of what they were getting into, especially the chiefs, who are the ones making the most in terms of money off of all this. So this is the last remnant of dry forest. So what probably covered maybe 300,000 or 400,000 acres. That's just my guess, at least on Maui and the Big Island alone. This little 2-acre parcel is all that's left. That, folks, is it. And pretty much in this one picture, you see all that's left of the Hawaiian forest. The largest single biotic system in the Hawaiian Islands, say 200, 300 years ago. Now, initially when they were studying this, the work was done by Rock in the 1880s and stuff, and the botanists, when they started to look at this, realized this was such a unique place, because they realized this was, you can still go, for example, in Kona, in the Big Island, and you can see the dead trees of the Milo and the various species like ko that you see here. You can still see the stumps, but they're not there anymore. So they realized very early on that this was what was left. And so there's been an enormous amount of study done on the Hawaiian dry forest in terms of what species are now extinct, what had happened to it, the impacts, etc. Having said that, if you notice, the ground cover here is still those stupid imported grasses, which is causing a huge amount of trouble in this area. But this is our dry forest. Now, what they didn't realize till the 1970s, let's see if I can do this. I think I should be able to flip back and forth. Okay. Pretty stupid thing. Okay, now this is only maybe, I'm trying to think here. This is about a quarter mile down the road. So this is about, 400 or 500 meters away from that other picture. It's a different day. But here you see, this is the same elevation. So this is the same elevation as that little remnant dry forest. Here what you see is what you might call modern dry forest environment. There's a few native plants in here. There's a real happy vili here. There's this absolutely horrible Sodom and Gomorrah thing, which is some sort of a unintentionally imported nightmare bush that's showing up, especially on Maui in this area. It's all over the place. It's absolutely horrible. It's also toxic to cattle, so it's a bad news in every way. But notice here, the rest of this is very much what we saw downslope. Here you've got Keawe, there's some Koahauli in this lower section, and you've got all these imported grasses. So this is the modern Hawaiian dryland landscape, if you would. This is all pasture. This is all part of the Lupalakua Range. So this section over here is part of Hawaiian Homes. This is Lualailua Hills here. So again, this is part of one of these rift zones. You can see your cones here. And this is all part of a late 1600s lava flow. So again, even though this is Maui, this is very recent. The Big Island's right over here. So what you're looking at is this dry forest region in its modern context. This is what happens when you still got tons of goats and cattle. And a little bit of remnant dry forest has actually got this huge finch, which is pretty good at usually catching and getting most of the goats. Though they still send groups in every couple of weeks to go and wipe whatever goats out to get in. So this is what you actually see today. This is the new system, if you would. Now in this one of the things that people didn't realize, because they were looking at this and they look at that other dry forest and they started thinking, well, geez, like how the heck, how the heck did that survive? Because one of the paradoxes, if you think of that other picture I just showed you, that area obviously doesn't get a lot of water. And so the puzzle they got into is how could you get plants like this survive in an area that has very limited water resources when some of these, like the ferns, actually require a fair amount of water. This was a huge puzzle they had, and they're really, for some reason, they really didn't address it. I'm not sure why they weren't more cognizant of it or more looking for a solution, but it just really wasn't something that was on their radar to try to figure out why they had what they had, what the puzzle was. In fact, here we go here. Let's switch here. Sorry, this Zoom just sort of clunky in this regard. Now, ironically, they actually had the answer in front of them. Now, we're actually really, in fact, the dry forest is on the other side of this ridge. So this is very close to that other image. And it so happens that if in East Maui, which actually, despite the fact you have the dry forest there really wasn't a lot of work being done on Maui. Most of the work was being done on the Big Island, which was probably a mistake for a bunch of reasons. The most obvious being that, as we'll see, the Big Island had changed the most climatically. On this part of Maui, if you notice, if you look back up here in the background, you see you've got high vegetation, we're back to grasses, and you got a line of trees here, vegetational line of trees. For some reason, the botanists, the tree guys that were looking at this didn't realize that this actually was trying to tell them something. And what it was trying to tell them is how these plants acquire water. This area only gets about 30 to 40 inches of rain a year. It's very, very dry. And by the time you get the goats and the cattle in here, you can see that even the grasses are marginal. So this is a real sort of bust up, very, near desert condition. In this, you still find clumps of vili-vili. And if you notice, if you look under the vili-vili here, you can sort of see, and this will zoom in at all. You can see that underneath the trees, not surprisingly, because of the shade and other aspects, there's actually more vegetation. There would actually be even more, but the goats love to especially dig and hang out here. So this area this has been wiped out by grazing animals. But this one here still got a little bit of this. This actually was something they should have been paying attention to, because the vili-vili was in some ways the cue. Let's segue out to another one here. A cue for what they should have been paying attention to. Oops. Vili-vili is found in the dry side of the islands. It's not a particularly attractive tree most of the time. As I'll show you in a second, it's got some beautiful blooms on it, but it's not high on the list of, scenic wonders that people are going to come from the mainland to go check out. And it doesn't have the symbolism attached to it that, say, the ohia does, which again is largely sort of a 19th, 20th century thing. So when you're looking at the vili-vili tree, what you're looking at is a really fascinating example of endemic Hawaiian vegetation. So this is one of the things that comes over here. There's a related species, I believe, from Southeast Asia. I'm not sure where else you find this. You'd have to go look. I don't remember. There's something at Rock about that. But it's an absolutely fascinating plant because it has become optimized for dry conditions. If you ever look at one of these things close up, well, if you look at these are sort of in semi-hibernation. So it's sort of, they're hanging around. If we look at one close up, let's switch this here. Okay, here's what I'd call a happy vili-vili tree. The vili-vili tree is real interesting because if you look at the bark, if you look at the surface of it, it's very smooth. It almost feels like skin, and it's got thorns. It's got thorn sort of pokies on it, but the skin is very, very smooth. On top of that, if you bang it or cut it, it's very, very thin. So it's almost like human skin. If you're familiar with vili-vili, it's used, for example, for outriggers on canoes and stuff. It's very light. This whole tree you could probably pick up and carry around easily, with little trouble. This branch you could carry around in one hand. So on one hand, they look big, but they're very, 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 very light. There's not a lot of substance to it. What you're looking at here is a vili-vili that's about 3 or 4 weeks after it, about a month and a half after it's rained. The vili-vili is actually in many ways like a cactus. What they do is the fact that they've got this very porous inner material and that they got this very flexible bark means that when it rains, it actually stores water in itself, just like a cactus does. So you can actually watch a vili-vili tree, for example, this particular one, which is where I used to camp. If it was dry, this thing would be about, maybe 1.5 inches around. If it rained and you went back about a week later, it'd be almost 2 and 2.5 inches around. So it can almost, it can almost 50% expand or contract the size of the limb in terms of water storage. And you can actually, I would suspect if you actually cut one of these down just after it had acquired water, if you put enough pressure on it, you could probably squeeze droplets of water out. So this plant has figured out how to store the water. It keeps a smooth skin on it because that limits the amount of transpiration. In other words, when the wind, which blows constantly, comes across here, if that plant has water inside, the last thing it wants to do is lose it. So what it's going to do is it's going to keep its skin as smooth as possible so the wind just moves over it and doesn't, grab hold and take water out of it. If you notice the branches here, if this is the ground here and this is the branches, what common factor did you see in these branches in terms of direction? Which direction are these branches all aimed?
The branches are facing upwards.
Yeah, no, exactly. Yeah. And I don't think the botanists thought about this. They just thought, oh, that's what it does. In this type of condition with this much sun, they don't have to look for sunlight. Vili trees always grow up. And it wasn't until a guy named Juvic was doing work on Lanai back in the 1970s did he realize that they had totally, because they were dependent on Western measurements, which is things like rain gauges, they totally misunderstood how you collect moisture in a Hawaiian environment. And the wet side of the islands, yeah, the vast majority of moisture comes down as rain, so it comes down as precipitation. On the dryland sides, they hadn't realized that that's not actually what happens. And I think in part because they were coming from a Western mindset, which is you measure rainfall, and rainfall equates to vegetation patterns. And that's sad to say, that's still the pattern that you see. You see very little attempt even today to measure, for example, the amount of mist that we get, say, in Manoa or Palolo valleys. But the Vili tree is designed for dry environments. So it's designed for high wind, very dry, high sun conditions, but it's also designed for mist. Now, if you visualize, and again, the easiest way would be go up to Napali in the morning when the mist is coming in. And this is something that you see on all the islands when you get to a certain elevation. The clouds, if you want to, the clouds come down and the mist comes across and hits the surface. Now, when the mist comes and blows through here, it's gonna basically start to blow across here and it's gonna beat up on these surfaces. If you ever stand in Nepal and you stand there and the wind blows in your face with the mist coming in, you'll end up with droplets of water in your hair and on your skin and stuff as it collects on there. So that's what happens here. So mist is gonna come in and collect on all these surfaces. Now, given I forgot who said that, but given which way the branches aim, what's going to happen when the mist forms as droplets? Where's it going to go? So the mist collects all the way up here. It forms those little beads of water. Now, because the surface of the skin is so smooth, where are the beads going to go?
It's gonna fall towards like the base of the tree.
Yeah, now normally you're exactly right. In fact, fall would be the word. And most plants, water would drip off. On this sucker, given the way this is oriented, will the droplets actually fall? If I'm a drop of water here, what am I gonna do? Am I gonna drop to the ground? Again, remember the smooth surface here. In fact, this would be even better. If I'm a drop of water here, I'm not gonna drop. What am I gonna do?
Like slide, kind of.
Yeah,
Not because, slide, but
yeah, no, exactly. This is almost like plastic. It's going to slide down here. Now, if I'm trying to collect as much, if I'm this tree and I'm smart, relatively speaking, in other words, I got a good design, then what that means is all the water that collects on my branches is going to run down right to my roots. So the Vili is like a giant catchment system that's designed to, where do I want to go here? This tree is a catchment system. If you notice the way these branches go, you get maximum elevation, so you catch as much of the mist as possible. In fact, you can see the mist right here. The mist was just starting to recede. It's probably about 10 o'clock in the morning, and the mist comes across Halakala between 7:30 and 9. So every morning the mist comes across here. If it goes low enough, it hits here. And notice how your two Vili trees are designed to maximize this. Now notice the Halekoa, which isn't used to mist, doesn't know what Halekoa doesn't know how to deal with mist. It isn't designed for it. It's a foreign exotic vegetation. It wants rainfall. These guys aren't interested in rainfall. Rainfall comes good, but they know it's not going to happen. So the Vili Vili is designed to catch that mist to maximize it. Because all this is a slick surface, all the water it collects is going to end up right here. Now, what that means is it's not wasting water that other plants are going to take. Every little bit of water it gets is going to go down here. Because of its efficient system, the water that lands here will then be sucked up into the plant. So Vili Vili trees are almost like a water vacuum. They take the water out of the mist, convert it to droplets, put that in the roots, and then through the roots to basically move it up into the tree and then store it for when they need. If enough of it shows up, then they very, very quickly bloom. And they'll go through the whole cycle. All of a sudden, the whole tree will be in leaves on the space of a week. It'll be in leaves for about a week and a half. The leaves will drop off. The beautiful orange blooms will start up. And within maybe a couple of more weeks, you'll have the very beautiful red bead seeds, which are used for lay, for example. Then those drop to the ground. And all those seeds, all this happens within the tree. So all the leaves fall down to the ground as fertilizer and protect the soil around the tree. They provide a cover. These seeds land down here. And so what you find in a Vili Vili environment is a very, very efficient, very strategized system of vegetation is designed to take advantage of this pattern. Let's pull this picture back up. Okay, so you go back to this particular image. Here you see the Vili Vili strategy. In fact, if you look at Vili Vili trees, you'll invariably find there's one that's the mother and the daughter trees. Here's the mother tree here. So what happens is these suckers collect all the moisture around here. They stash it in themselves. They don't share it. Now, if this was a normal other type of species of tree, there'd be water all the way around here as the water drops off on the ground. So there'd be higher vegetation because of the better water. If you notice, there's no advantage to anything else. The Vili Vili doesn't want to share. So what it does is it drops down here. Now, over time, the seeds that are dropped, the ones that are most likely to survive, are the ones right close to the mum. So you see this keiki over here, and this is another keiki over here that are related to the mother tree. Eventually, the mother tree will die, and what you'll see is a clump of Vili Vili, and they'll go through the same strategy. Notice how this one's got a keiki next to it. So what you get is clumps of trees and then a bunch of nothing. And here's one that's pretty much probably dead. It looks like the goats got it. And then you're going to have nothing over here. At some point, if another Vili Vili, if it rains really heavily and there's seeds around here, you might get another one start up. So it's a very, very efficient system that basically gives you a little tiny biotic package that's entirely driven by the tree. Now, as we'll see, the Hawaiians realized how this worked, and they would very astutely both plant Vili Vili where they thought it would work, and they would also use this. So if we suddenly segued to 1600s, you'd find that Hawaiians would plant sweet potatoes around here, which served two purposes. One is the sweet potatoes would help get some of the moisture from the trees. Secondly, the sweet potatoes would keep the land temperature down, so the Vili Vili was better at capturing water. So the Vili Vili gets more water, you end up with food. The more food gives more water. And so you end up with this little symbiotic relationship between the vegetation down here, the tree here, and the way that it gets manipulated. So rather than tearing these out and trying to irrigate it, which the Hawaiians couldn't do, it wasn't possible with this landscape, what they did is they took advantage of the existing plants. So this is a very typical Hawaiian endemic landscape, and this was the dry forest. The dry forest were these very sophisticated, very opportunistically designed plants that did a superb job of dealing with very limited conditions and depended almost entirely on mist for what keeps them alive. And with it, what you're going to find is under here is now a whole list of extinct species that would have only lived underneath the Vili Vili trees that took advantage of this and probably had some sort of symbiotic relationship with it. It's important to remember, for example, sandalwood, iliahi, is a parasite. And you'll find iliahi on Vili Vili trees. So what you find here is you even have other tree species that parasite off of tree species. Again, in this very close, intimate relationship. And all this area here would have been probably bare rock and clumps of peely grass, till you find another packet of Vili Vili trees. This part of East Maui is the only area I know where you still find a lot of Vili Vili clumps, and you can see this little sort of miniature ecosystem tied to these plants, but it still requires that you have the mist. Let's see if I got a picture of the mist here. Yeah, here we go. Now here, this is the edge of that dry forest section I talked about. Notice here's where the goats are. Here's where the goats are. So this gives you some idea. Now notice the lack of vegetation here, the lack of ground cover. This is one of the areas they've cleared out. If you don't have the goats around and you spend a huge amount of effort, this is what this would have looked like a couple of hundred years ago. Now this happens to be a real nice little pocket, which is one reason it probably survived. And you can see the mist right up here upslope. For some reason that oozes down over here and collects in here. So this can actually be sunny, and right in here will be a little bit of what almost looks like fog, which is this mist, which is one reason why the dry forest probably survived in this particular location. But notice the difference between this vegetation pattern and this. This is the vegetation pattern in this area in 1780. By 1820, with the introduction of large numbers of grazing animals, it had turned into this, and this is gone. Now, one of the side features of this, and you can see this here, most of these guys here are, here. Yeah, it's all here, got here. I can't remember what that one is, not Ali, I can't remember what it is. So what you've got here is a mixed system. Your main plant here is going to be ohia. This was the other main species in the dry forest. So the vili was probably a better strategist in terms of really dry conditions and mist. If you have a little more mist, and it's probably more durable is the ohia, which is a lot tougher. It's a lot harder wood. It's a lot more durable. So what you're going to get is ohia will also clump. Now you find ohia as low as about 150-foot elevation. You also find ohia, and again, remember what I said before, a lot of Hawaiian species, now I should point out, for example, vili doesn't, but a lot of Hawaiian species are very, very good at surviving in very, very diverse conditions. And what do I do with my pictures? Oh, here we go. So remember, we're still in the dry forest. This is that same dry forest at about 5,500 feet. So we're way up the side of Halakala. If we went and fell right downhill here, we'd land right in the middle of that little remnant dry forest at lower elevations. Now, this is a modern one, so this still has grazing animals, so it's hugely impacted by that. But if you notice, your major species here is ohia. You've got a few exotics over here, but most of this is ohia. There's a little bit of, I can't remember the other species. One of the Hawaiian hardwoods will occasionally hang around. But now these are ohia trees. If these were down about 1,000-foot lower elevation, maybe at 700 or 800-foot elevation, this particular plant would probably be about 10 to 15 feet tall. It'd be an ohia tree, like the ones you're generally most familiar with. At this elevation, this is exactly the same species, but it's now shrunk. So whereas in most of the rest of the planet, if you went into this area, which would be called near alpine conditions, what you'd see is a different plant system. There'd be a different biotic pattern of plants that are optimized for high altitude, colder conditions. This area is always cool. And in fact, this area gets frost in most of the winter season. It's a lot of time up here. It's maybe in the high 30s in the morning till it starts to warm up. And again, you see your mist cloud formations here. So this gets a fair amount more mist. Doesn't get a lot more rain. Gets a lot more mist. It's cold. So what happens is rather than different plants, what you see is the same plants that have optimized themselves. Because it's cold, because ohia doesn't have natural like antifreeze in it to deal with cold, the plants hunch down close to the ground. So they're huddling down here, but it's the same plant. Now, if you were to take one of those ohias, for some reason you decide you're going to dig this out of the ground, you're going to take it and plant it down in your house, say, in, I don't know, in Palolo or something like that, the sucker will die. It's become used to the very harsh, cold, dry conditions of that spot. And you can't, even though the species is the same, the individual plants have become sort of fixed in their location. So on one hand, this is an incredibly durable environment. I mean, these suckers have even survived goats and cattle. But on the other hand, they're not, it's durability, but with real clear limitations in terms of, what that durability means. But this is your upland environment. Let's go a little further upslope here. Okay, now we're way upslope. This is near Poli Springs, which is over here. And I see there's actually several things in here. When you get a classic image of the mist, you see the mist rolling across here. And again, it comes across every morning. There's very little rain down here, but the mist comes in maybe 3, 4, 5, 6, 7 days of the year or of a week. So the mist comes across here. That's the only moisture most of the stuff's going to get. Here you've got the native Hawaiian poppy, the little yellow flower you see here. Again, you can find these suckers all the way down to about 300 or 400 foot elevation. The Anohea, I think, are probably symbiotic. They have some sort of complex relationship. I've never figured out, and I've never seen anything written on it. There's been almost no work done, weirdly enough, on Hawaiian plant durability. Everyone's so fascinated with the disappearing species that almost no one's doing work on the ones that are survivors. So, you know, this area, I don't know, this area hasn't been hit by the huge dieback yet, I don't think, and it might not. It might be too high elevation for it to be effective. But here what you see is, again, now these are exotics. These are imported trees that were brought in to basically forest this area with the idea that these trees would be harvested. So again, people were trying to, in the 19th century, were trying to figure out how to make money off of this. This elevation is too high for cattle. The goats go up here, but even the goats don't particularly care for this elevation. The grasses, notice how limited the grasses are. It's too cold for most of them. So in some ways, if you got rid of the green grasses and you got rid of the sort of pine tree looking stuff, the rest of this would be exactly what it would look like, you know, 300-500 years ago. And notice here how you've got your rift zone. This is the rift zone I showed you the image of before up the side of Halakala. So this is this one cinder cone after another. This is that huge crack in the ground that went all the way down to the Pu'umohoi and the other cones at the coast into Makali'i offshore, that offshore one. This is the upper part of that same rift zone. So this sucker here, though it looks a little bit tiny, is actually about 800 to 1,000 feet higher than this area here. So these are actually quite large and they're very impressive. So all this is your Hawaiian system. And this is your Hawaiian land system. This is your upland or alpine, subalpine land. Now, the thing to remember that makes this such a striking area, and to be honest, I don't know why more research isn't done in the Hawaiian Islands, especially in my view, Halakala, since I'm biased, is that you have to realize that, that if I take my motorcycle, my dirt bike, up from the ranch down here, where that dry forest is, and I struggle my way up the ash trail up here, this is about a 45-minute to an hour drive. In that process, I've gone over about 7,000 foot elevation. This is about 7,200 feet. At that, I've also gone through 5 different climate zones. If I were to do that, even for example, in the Rockies or someplace in the mainland, that would be a couple of hours drive, if not a good part of a day. Here, I can actually stand up here. If I were to stand up on a high spot here, I can see all the way down to the coast. I can see every environmental zone all the way down to the strand at the coast. And I can also see upslope to the near alpine conditions that you see here, where no trees can survive because it's too cold. So in the Hawaiian Islands, what you have is this very compressed system of this huge diversity of conditions in a very, very small piece of real estate. And that's probably one reason why your plants that can optimize themselves to take advantage of variable systems end up as your dominant plants. It's not by accident that you find ohia all over the dryland sides of the islands. Why? Because the bugger figured out how to survive near the shore, and it figured out how to survive at 6,000 foot elevation. And it keeps exactly the same. It's the same plant. It's not a different species. Almost anywhere else in the world, you'd have different species doing this stuff at different elevations. Not here, not in the Hawaiian Islands. So when you're looking at these different zones, some of the plants move through them. Others, like the Vili stop. Vili can't handle cold, not surprisingly, because its skin's thin, it hides moisture inside. Frost would kill it. The frost would literally blow the tree apart. So Vili, you only find it to about, at least here on the side of Halakala, about maybe 1,500 foot elevation. It's a different strategy. It's doing a different type of thing. Same conditions, but different ways of dealing with it. So if you think of, on one hand, this, so there's got to be a more elegant way to do this. And on the other hand, this. What you've actually got is, you know, you could stand up in that spot I was before and you can see this. We're now at about 600 foot elevation in an area called Hokukamo and Oahe. If you're familiar with that area, this is the wind farm that went in right over here, much over protest of folks like me. Now what you get here is two things. One, notice your part of your infamous group, though this is the cattle. No one really bought, cattle don't piss people off too much. What you don't see is in this same image, I'd be willing to bet there's probably 50 to 70 goats that you can't see, which is one reason why we shoot them on site. They've devastated this place, but notice the lack of grass. That's partially because it's dry, but that's mainly because of things like this. Just eating everything they can get in sight. Now notice we've got our vili trees, these scrawny sort of dry looking sort of beat up buggers. These are all vili, and here's a crump, here's the mama, and here's the keiki here. Here's one sort of doing its own thing. Here again, you can see a clump. So again, vili does its thing in a very consistent pattern. Here's one of your imports. This is the agave, which, or aloe, I can never remember what it's called, something like that. It's what you make aloe. I guess it must be called aloe. This is the pulp that you guys use for aloe sunburn something. What you might notice here is you might see something that looks sort of striking because it looks pretty regular. This is actually a Hawaiian village site. The Hawaiian, this particular location has a little bit of water coming in. Here's a gulch. In the period prior to, the introduction of grazing animals, mist used to come down to this zone, which is one reason why all the villis are here. So this area used to it didn't get a lot of rainwater, it got almost none, but it got a fair amount of mist, and the conditions were actually pretty decent. So you could grow a fair amount of, for example, sweet potatoes in this environment. So by about 300 years ago, Hawaiians had set up a small community here, sort of opportunistic. There's 3 or 4 house sites. 2 of the house sites are right here. So people lived here at least part of the time, maybe not full time. And they took advantage of this lower section here and planted sweet potato and had cute little clever dams set up. So anytime it did rain, it'd catch the water and shovel it to the plants. And this was a viable community. Here you can see there's large amounts of vili even today. So this was actually Hawaiians taking advantage of the existing conditions provided by the plants and then optimizing that for human habitation. Now, of course, all this goes immediately south the minute the grazing animals show up. And then you end up with your koa haole here. You've got kiawe, you've got the agave or aloe, whatever the hell that's called. Here's your kiawe over here. So this has been completely, modified, but there's still little remnant pieces of this old land in here. And this again is unique because if you go to the Big Island, you don't see the vili like this, and you don't see this landscape. There, the grazing animals have been much more destructive. Molokai, they've been much more destructive. So this part of Maui is probably the last piece of the Hawaiian Islands where you still see sort of a hint of a pre-European landscape that in many cases is actually pre-Hawaiian, because your plants like this and the way that they're operating has nothing to do with Polynesians. The Polynesians were smart enough not to destroy it, but it predates them by hundreds of thousands, if not millions of years. So that's our sort of dryland environments, which are in many ways the most complex in the Hawaiian Islands and by far the least understood. So if any of you are environmental studies majors and you want to do something useful, I'd strongly recommend you start taking a look at ways this actually functioned and ways that you could manipulate that in a modern context. Okay, so we'll stop there. Okay, any questions or anything like that? Do the slides sort of work? I mean, do they give you a better idea what I'm talking about?
Yeah, they help.
Okay. It's so clunky switching back and forth. It's sort of, I'm not sure whether it's useful or not, but I can't see of any way to describe it. And so, okay, we'll stay with those. We'll probably see a few more as we get into wetland conditions. So let's see, anything else that we need to go over? We're all good?
So I noticed, so the videos, did you say that they're uploaded to YouTube?
In this class, no, they're what's it called? They're called Panoptos. They're actually in the Canvas website.
Okay, gotcha.
Yeah. The 200 class, I'm uploading them to YouTube, but I decided that since my YouTube stuff is public, I didn't want the class captures on YouTube because it's got your names on it. So if it's in Panopto, the only people that can see it are the same people who would, be registering, would be in the Zoom.
Okay.
Yeah. So no, we won't do that. I was gonna do it. Yeah, it's a good question. I was gonna do it originally. I realized no, I have problems with sort of privacy issues. This way, you guys can be comfortable. It's not, you know, it's not going out there over the ether for everyone to check it out. I don't know why you guys would care, but you know, it's just safer that way. So yeah, so if you go to Canvas, you'll find the videos will be embedded in that one. In fact, when the class is done, as soon as I can, I'll upload this and I'll put it into Canvas, and this video will be in there for you guys to use if you want.
Okay, thanks.
Any other questions? All good? Okay. In that case, I guess I'll see you guys next week. As I remember, Monday's a holiday, and I hope today's Friday. So we'll meet again on Wednesday, I guess, yeah? So in that case, see you guys later. Have a good weekend.
Bye.
Have a good
Thank
day.
you.
Bye-bye. Take care.
Thank you.